Now, finally, we're at question 3. Now, question 3 is geometry. All right, and it says using a ruler, a pencil, and a compass, construct a triangle LM 12 centimeter, MLN 30 degrees, and LMN 90. Credit will be given for clearly drawn construction lines. So of course it's difficult for me to construct right here. Not sure how to construct, but just to show you a glimmer of what to do, just draw some line, right? Just draw a line. Just draw a line. It don't matter yet. Just draw a line. All right, just draw a line. Now, once you draw that line, all right, you need to create a 90-degree angle. All right, so this line that you draw, then now you can measure out to make sure it is 12 centimeters. All right, so let's say this is 12 centimeter. All right. LMN, so the angle at M is 90. So be careful, the angle at M is 90. So if you label this as L and this as M, then you want this angle to be 90. So to get this angle to be 90, all right, you need to get this angle to be at 90. So you know that you're going to open up your compass, all right, and you're going to swing arcs both ways. You're going to swing arcs, all right, and you're going to get that, all right. So I'm just doing a rough sketch of what you should have, all right. You know that this angle should be 90 degrees. Then you're going to have to, you know, draw up this now. And what else it tells us? It tells us that MLN is 30 degrees. So you need to make sure that the angle right here is 30 degrees. So when you do your construction, you know, and you're swinging your arc and all of these wonderful stuff, you're swinging your arc and some stuff like that, that angle should be 30 right here. How can I show these without? You swing up your arcs and all of that beautiful stuff, then you know that that angle should be 30 right there. This is far off. These are just rough sketch. So all it is saying is this angle should be 30. All right. I'm unable to do all of this, but this is just a schematic of what you should have. This angle at L should be 30. The angle at M should be 90. And this here distance, your LM is supposed to be 12 centimeter. All right. So when you do all your sketching up and all of these things, talking about swinging an arc and all of that lovely stuff, that's what needs to happen. All right. This is how your diagram should look. All right. Just a schematic of what you should have. So I just want to point that out, that this is just a schematic of what you should have. Schematic of what you should have. Right? So that's just construction. Now let's look at this question now. Back to the real mathematics. All right, because construction is so boring. Now, back to the real mathematics. It says triangle ABC with vertices A, B, and C is shown in this diagram. And it's a triangle ABC is mapped to LMN by a reflection in the x-axis followed by a reflection in the y. So then tell we say them reflect it in the x-axis. So if they reflect it in the x-axis, this will be A prime, this will be C prime, and then instead of 1, 4, it's going to be 1, -4, and this is B prime. All right. So this is when you reflect it in the x-axis first. So you have A prime, B prime, and C prime. That's what happened when you reflect this triangle in the x-axis first. So everything go below the x-axis when you reflect it in the x-axis. All right, so reflect it in the x-axis first. Then the next part of the question say, boom, we're going to reflect it again now in the y-axis. So let's go ahead and reflect again in the y-axis. Now going ahead and reflecting again in the y-axis. So we're going to reflect this over here. This is the y-axis. So A prime is going to be here. I'll reflect it in the y. C prime is going to be 1, 2, 3 away from it. It's going to be 1, 2, 3. So this is where C prime is going to be, or C prime prime. And then this is where B prime prime is going to be. All right. And in this case, they don't call it A prime prime. They call it L, M, and N. Well, actually, this would be A. A would be for L. M would be for B. Wait, yeah, I put B at the wrong spot. This shouldn't be right here. My apologies. 1 unit away, 1 unit away. And this would be your B, which is M. And this would be your N. And then you go ahead now and just draw up your triangle. Make it look presentable. Again, I'm not using the straightest of lines, so it's gonna look away sometime, but it is what it is. So this is what you have. This is the final diagram. All right, nice and easy. What else are they asking us to do? On the diagram, draw a triangle LMN. This is it. This is it. This is it. This diagram right here is LMN. So we're done. All right, so we'll take it that we're done. Nice. Now it says describe fully the single transformation that maps triangle ABC onto LMN. Now the single transformation, 90 degrees, well, we reflect it through the X first, then reflect it through the Y. So we want to find out what's that single transformation where we put those two together. Reflecting it through the X first and reflecting it through the Y. What some people do is they write down the 90 degree, they write down reflection in X-axis, matrix, write down reflection in Y-axis, multiply them, and then that will give you the matrix that will tell you what is happening. But I don't like doing it that way. That's a long method. Look at what we're going to do. We're going from A to L. All right, so look at this. We're going from A to L. This is how I like to do it. I like to write down what A is. A is the point 1, 1. And then what happened to L? A is then going to be mapped to L. And what is L? L is -1, -1. You see what I want? -1, -1. All right, that look like 180 degree rotation, don't it? That look like a 180 degree rotation for this end up negative. So can we check and see if I see anything up for B? B happened to be 1, 4, and this happened to be, M happened to be -1, -4. So clearly it's 180 degree rotation in the counterclockwise direction. All right, going this way, so it's a counterclockwise direction. Well, actually, it wouldn't even matter. Whether you're going counterclockwise or you're going clockwise, it's the same thing. It's just a 180 degrees rotation, because B is the point 1, 4, and they go to -1, -4. So the single transformation is, we can say that this is a 180 degrees reflection in the clockwise direction, or if you want to say counterclockwise, because whether you go clockwise or you go counterclockwise, it doesn't matter. It really doesn't. You're still going to get the same thing. All right. So whichever you may prefer to write. I like to be positive, so I'm going to say clockwise. All right. So just looking at the points, we can say this is clockwise. Just to stay positive. So describe fully a single transformation that maps that onto that. So triangle ABC is mapped. Triangle ABC is mapped to triangle LMN by a 180 degrees reflection in the clockwise direction about the origin. Always put about the origin. All right, that's extremely important. All right, so that is what is happening. So the triangle ABC is mapped to triangle LMN by a 180 degrees reflection in the counterclockwise direction about the origin. All right, and that's that. Now the next part says, state the 2 by 2 matrix that maps on triangle ABC to triangle LMN. Now, the matrix is going to be, because it's 180 degrees rotation, it's -1, 0, 0, -1. All right, that is the rotation. Just off memory, there's a formula that can actually work out these things. All right, I've been telling myself this formula for many years now. Many years. I use this formula. R of theta is equal to cos theta minus sine theta, cos theta. All right, this formula is very effective because this formula will tell you the matrix transformation very easily for any rotation or reflection, any one of them. Because this, we said it's a 180 degrees reflection. So when you put in 180 in this now, look what you're going to get. Putting in 180, you get the cos of 180, and the cos of 180 is -1. The sine of 180 is 0. So these are 0. All right. And the cos of 180 again is -1. And so that tells you that this is the matrix. So this is just a simple formula that I use to remember matrix transformation. So if it's 90 degrees rotation, I put in 90, everything will work itself out. If it's 90 degrees in the counterclockwise direction, I put in -90 as theta and stuff like that. It always works out. So this formula is extremely powerful. If you want to know it, that is, or you can go ahead and memorize matrix transformation. All right. But I use this so I don't have to memorize anything. I just always go back to this formula and plug in the degrees of rotation or reflection. So that's part